Hello. This is a video on using linear inequalities in one variable to make predictions. This video is being made for my Math 100 students. I encourage you to take out your Math 100 3.5 information sheet and take some notes. First of all, let's go over the symbols, which are right here. The first one is less than. It points to the left. That's less than. The second symbol here is less than or equal to. The third one is greater than. The next one is greater than or equal to. The line underneath is kind of for equals, and not equal. And we'll be seeing examples of that throughout the video. Important note, when you multiply or divide both sides of an inequality by a negative number, you must change the direction of the arrow. So less than will become greater than, for example, and we're going to be seeing some examples of that. First thing I'd like to do is explain what these things mean with a graph on a number line. So let's come down to the interval notation. So the first example is x is greater than 7. What does this mean? On a number line here, let me see if I can get my pen here. There we go. We make a number line. Please put arrowheads at both ends because it goes to positive infinity and negative infinity. Please put 0 on all number lines. And we like to have x being, we like to have the positive numbers going to the right and the negative numbers going to the left. If you want to do it the other way around, you can, but potential for confusion. X greater than 7 means that x is larger than 7. It might be 8, 9, 10, 50. It also might even be 7.1. The way we indicate that is by putting an open circle on 7, which means 7 is not included, but an arrow going to the right. This is our first one. The second example is x is greater than or equal to 7. So the second one here is going to be similar. Maybe you can anticipate the difference between the first graph and the second graph. This time we're going to have a filled in circle on 7 and an arrow going to the right, because 7 does make that true. 7 is greater than or equal to 7. Now I'd like to look at the interval notation. This interval notation and this interval notation. Look at the similarities and differences. First of all, it goes up to positive infinity, which means it goes to the right. The first one, for x is strictly greater than 7, we have a left-hand parenthesis, which means 7 is not included. We would have an open circle. The second one, we have a closed bracket, a square bracket, which means 7 is included. Now I'd like to go to the third example, x is less than 7. And let's make a graph of x is less than 7. We're still going to have 0. We're still going to have positives going to the right. But now we want to be smaller than 7. So we're going to have an open circle on 7, an arrow going to the left, so we'll have 6, 5, 4, 3, 2, 1, but also -5, -10, -1,000. And that's going to have an interval notation, negative infinity to positive 7. Notice that we have parentheses, which means 7 is not included. And finally, our fourth example is x is less than or equal to 7. 7 is making this true, so we put a closed circle there and an arrow going to the left. Now I'd like to do homework item number 5 from the homework from section 3.5. Here we are looking at the book, the homework for section 3.5. And let's drop down and look closely at the directions for questions 3 through 32. Solve the inequality. Notice that these are inequalities. These are not equations. They have less than or greater than, for example, in them. And we need to do three things. First of all, we need to have an inequality. Secondly, we need to have interval notation. And third, we need to have a graph. The most common mistake on exam 3 is forgetting to give all three and not following the directions. We need to give an inequality, we need to give interval notation, and we need to have a graph. And I'm going to be doing number 5. Number 5 is negative 4x is greater than or equal to 12. Negative 4x is greater than or equal to 12. I am going to divide both sides of the equation by negative 4 because it's negative 4 times x. But the important thing to realize here is that the direction of the arrow is changing. If you add or subtract, you leave the arrow going the same way. If you multiply or divide by a positive number, you leave the arrow the same way. But if you multiply or divide by a negative number, you must change the direction of the arrow. So here's the first part of my answer. The second part of my answer is going to be a graph. Here's 0. Negative 3 is over here. I'm going to have a closed dot, and it's going to the left because it's less than. And the third part of my answer is going to be the interval notation. It is going to negative infinity, which I should put on the left. It's coming up to negative 3 with a closed bracket. So these are the three portions of my answer. Now I would like to do number 15 from the homework. Same directions. Solve the inequality, state an inequality, interval notation, and a graph. This is number 15. 3 minus 2 times the quantity x minus 4 is greater than 4x plus 1. First thing I'm going to do is use distributive property with negative 2. This is 3 plus negative 2. So as I use the distributive property, I'm going to have negative 2x. Negative 2 times negative 4 is positive 8, is greater than 4x plus 1. Now I'm going to add like terms. 11 minus 2x is greater than 4x plus 1. Now I'm going to add a positive 2x to both sides and subtract 1 from both sides. That will leave 10 on the left-hand side and 6x on the right-hand side. Now I'm going to divide both sides by 6. Since I'm dividing by a positive number, I do not have to change the direction of the arrow. 10 over 6 is the same as 5 over 3. So this inequality would be a correct answer. 5/3 is greater than x. But 5/3 greater than x, what does this mean? This is equivalent to x is less than 5/3. And you might take a look at that and make sure that that makes sense. The larger one is 5/3 and the smaller one is x. It's still pointing toward the x. So this is our inequality. Either of these would work for that. Now we're going to have the graph, the number line. Here's 0. Here's 1. Here's 2. 5/3 is 1 2/3. So we're going to have an open circle here at 5/3. And it's less than, it goes to the left. The interval notation is going to go from negative infinity up to 5/3. If you want to use a decimal, that's fine. It does not include 5/3, so we use a parenthesis. These are the three answers for number 15. In my final example today, I would like to take a look at this applied problem where we're comparing two rental companies, one budget rental company and the U-Haul rental company. And we have two functions here, B of D for budget and U of D for U-Haul. And the question that we're asking here, for which mileages does budget offer the lower price? we're going to be using these two formulas for budget and U-Haul, and we're going to make an inequality. We want budget to be lower than U-Haul. So we take the budget expression, then we use less than. Less than means lower than. And then we have the U-Haul expression on the right-hand side. Then we have some algebra. I'm going to add a negative 39.95 to both sides. I'm going to add a negative 0.49d to both sides. I get this inequality. Then I divide by negative 0.3. Here's another example where we're dividing by a negative number. When we divide by a negative number, the inequality symbol needs to be reversed. So less than becomes greater than. So we get D is greater than 66.7. D stands for the number of miles driven. So the answer to this question is, if we drive more than 66.7 miles, then the budget truck is less expensive. I hope you found this video useful. Remember, if you have any questions, you can come to my office and ask questions. Good luck on the 3.5 homework. Have a great day.